All right, so this is a customer that we've been dealing with for the last couple months. I say dealing with, I don't mean that rude or anything like that, but this guy's got a York heat pump. It's not going into defrost. I was out here a couple days ago, trying to figure out what's going on. Everything seemed like it was working. It just wasn't going into defrost mode on its own. I was able to jump start it and get it going manually, but it needs to do it automatically. So right now we have the disconnect off. We had left it off from the other day. The condenser motor, that's this guy up top, he is showing some issues here. He's got some leaking fluids and stuff, which we took a bunch of pictures and showed the customer last time. But what we're doing is we're gonna have to remove this to get inside and deal with the coil sensor, and I will kind of show everything over here in a second. So for those of you that are in the HVAC trade and you're trying to figure out exactly how I was able to figure this out, on this defrost control board, we've already replaced it in the past. That's what we originally thought. I was trying to do it from the test pins here in the back corner. You can kind of see them, they're hiding, but right here, those are the tests to test defrost. The paperwork and the manufacturer for the equipment says that you should be able to hold them and touch them together for 6 seconds, and then it'll force defrost. It never did. So we replaced the control board, figuring that was going to be okay. It continued doing it, didn't realize that it had a coil sensor because the one that is inside is actually hidden by some sticky insulation stuff. So this is that coil sensor here, this blue wire here. This is your ambient temperature sensor, which is sitting under here. So this board has an algorithm that is already pre-programmed into it to determine the temperature of the coil and the temperature outside, and that if there is a disparity between the two for too long, it'll go into defrost mode, keeping all the hot refrigerant out here, and then taking any of the ice and frost buildup on the outside here and dropping it down. So with these sensors, they are all rated in 1,000 ohms, so K ohms. Or kilo ohms. So in this case, you want to take your multimeter or voltmeter, and you want to go to this setting here and make sure that you have, hold on, I need to make sure it was on right. You want to make sure you have, this says M ohms, but you need to make sure it says K ohms, just because it is what it is. But what we're going to do is you want to take one lead, put it in one end, and one lead and put it in the other. So this one, because it's been sitting long enough, it says it's good, but we know it's not, because after numerous tests with this thing, it wasn't working. So we have everything here, and now it's saying it's 27.1 K ohms. That technically means it's okay from what I understand, but we're still going to replace it anyway, because one, we already bought the part, and two, it was wrong, or it was bad when we had initially tested it. So with that being said, we now have to take this and detach it from all of this. It's got, I think it was like 5 or 6 feet of wire, or 55 inches, so close to 5 feet. So we have to pull all this out, and then we're gonna pull it out from here, and then we're gonna take the top off, get down inside, and detach all of that. So side note, this is kind of what I was talking to earlier about how it's kind of seeping stuff out. You can see all this dirt and dust build up. It's kind of caked, it's really caked on there. So this stuff doesn't just happen over time. It well, this does, but in the cause of it doesn't. So if you can see, there's a slight color difference, right? So right here it's a little darker than here. This is your standard this is your standard. You know, it's a lot easier to determine the other day. Nonetheless, you have color difference here, which means that one of these two colors, probably this one, because of how it's angled, how it's mounted. This is going to be all of that oil and lubricant inside the motor. This is what's going to determine this as a bad motor. So clearly it still spins and it still runs, and there's no issues there. It is quite dirty, which that's fine, I guess, but that oil is then going to leak onto your shaft, and there's not a ton of shaft play, but there is shaft play to begin with, and you can see all that dirt and debris there on the shaft. That's all oil and stuff. I've already talked to the customer about replacing the motor. but he wants to make sure that the defrost cycle for the system works before he spends any more money in this, or for this unit. And while we're in the unit, I'm gonna go grab my vacuum so I can vacuum all this up, but we're gonna quickly go over everything that's kind of included in this. So this is your reversing valve. I was referencing it in a different video. So this is that brass tube that goes, that's horizontal. Then you've got 3 brass copper tubes that come up. In this case, you've got 1 that goes down. That goes into the compressor, which this is a sound blanket. It's also a heating blanket, so we're okay there. So this is not what your compressor looks like. It looks like that guy, just a little different, and it sits here. That's your accumulator. This is kind of like a backup tank, if you will, of certain oils and refrigerant levels and stuff like that. And then this is going to be your TXV. This is your thermal expansion valve. So that essentially meters the refrigerant going into your coil, which is what this is. This is your condenser and coil. That gray bulbous thing back there, that's called your filter dryer. That filters out any non-condensables and any particulates or particles that are in the refrigerant lines that shouldn't be. There's a way to determine that, if that's bad or if that's plugged. You just take clamps and put it on either side. And if it's more than a 3-degree difference, then you have too much restriction in the filter dryer and you need to have it replaced. Anytime you open up your refrigerant system, whether that be at the air handler or coil, whether that be here replacing the compressor, whatever it be, if you open up the system, you have to replace your filter dryer. So that's what you have to replace that if you're going to open up your system at all. It's because if there's any particulates in there, we want to make sure that a fresh filter gets it all, rather than having a used filter try to get it all. That's like putting a dirty air filter back in your furnace. The part that we're going to be replacing is that guy right there, the one that's wrapped with the black foam. So that is our coil sensor. Let me see if I can. That's the best I can do. So that's your coil sensor. It's the blue. It's currently kind of taped over, but it's easy snap on, whatever, and then it just follows wires through there and then through the other side to the electrical panel. And like I said, we have to just unwrap all this and call it a day. So this is what the new sensor looks like. So this is what it looks like down there. It's just covered with that sticky residue. But so this is the sensor. It senses the temperature of the coil or the refrigerant that's going through the coil, essentially from one end around to the other through this guy, and then that communicates back to the control board, and that determines defrost cycle. And that's garbage. All right, so we got the new sensor in, and instead of reusing this crappy non-stick foam tape, I don't have any more of this, so we have to end up using the gray duct sealant pookie tape, that guy right there. But did get the new one installed. It's not, that tape's not great, but it'll do the job. It'll keep the moisture out for the most part. That pookie's pretty good when there's a need for it. So now we're just gonna do some cable management. I'm gonna run back to the van, grab my vacuum so we can clean this out as well. But I'm gonna do some cable management and zip tie all this back together. I had to break the zip ties, or cut the zip ties that were holding everything together. Then we're gonna come back in here and take this wire and run it with the rest of this, bundle this back up, plug it into the board, and then we got to run everything and make sure it'll go into defrost on its own, which, with it being off for as long as it was, it's gonna be fairly time consuming to test it. All right, so we got the wire, we got the sensor wire plugged back in. So we've got it plugged back in here. It's not polarity sensitive, so it doesn't matter which wire goes where. There's a coil G. I don't know if you guys can really read it, but right there you can kind of see where it says coil G-ish, and then in between them it says coil. Like I said, it's kind of tough to read. There it is. So coil G on the left, coil on the right. They're non-polarity sensitive, so it doesn't matter which direction we go. Obviously, we have zip tie here. zip tie here, and then a zip tie in the back. So that's cable management. Then moving in here, we have the zip tie here, the zip tie here. This holds everything together. This foam here is to make sure that the vibration coming from the compressor coming through the lines doesn't wear out any of the insulation, which then can also wear out spots on the copper line, creating leaks and issues there. Obviously, we have the sensor down here wrapped in its fancy new tape. So we're all good to go. Now we're just gonna clean all this out because that's something that we said we were going to do a couple days ago. So we're gonna do that, and then we're gonna put everything back together and turn the power on and start her up. All right, so it's not pretty, but we do have all the loose debris out of there. My hoses are pretty dirty, so I'm gonna have to clean them when I get home. But this is, again, with the exception of the actual dirt itself, that stuff will wash off. The green is the algae that build up from over the years. But this stuff, you need to be able to clean clean the inside of your heat pump or AC as often as possible, preferably at least once a year when you're having it looked at. So we're gonna put the unit back together and turn it back on and hope for the best. All right, heat pump's been turned on from the thermostat. Customer is updated with the information on what's going on, and now we just wait. All right, so we're all done with that job. Everything seems to be okay. As I was explaining to him earlier, it is a demand defrost control board. I realized that I had now enunciated both of those words a little differently and or backwards, but it's a demand defrost control board. So that means that depending on the algorithmic setup between the coil sensor and the ambient temperature sensor, that's going to determine when it goes into defrost. So I'm not going to sit around for anywhere between a half hour to 4 hours. So unfortunately, it's one of those hurry up and wait situations once again. So we have to make sure that, so he's going to go run out and do some errands and come back. And if it's an ice ball again, we've got other issues, which wouldn't make any sense, only because of the fact that the only two things that would affect the defrost timing and the defrost sequence have been replaced, outside of the ambient temperature sensor, but that ohmed out to be just fine. Both the original day that I had tested it, and then the day that I was out here last, so 2 days ago. So 2 out of the 3 things were replaced, and all 3 things were verified to be in working order. So if it still doesn't, then I don't know what to do next.